Hello, everyone. My name's Justin Pollock, and I'm here to talk to you about a very interesting case here with the OnGo Alliance and Nextlink and Alpha Wireless, where we came together and solved a problem with a 3.5 gigahertz deployment to help provide high-speed internet to rural communities. So let's just jump right into it here. So next slide. There we go. So I'm here with Cameron Kilton. He's the CTO of Nextlink Internet, and myself are in the middle here. I'm a senior product engineer at Alpha Wireless, and then Tim Sill, he's our VP of Technology and Business Development with Alpha Wireless. Do you guys want to say hello?
Hey, everyone.
Thanks for joining us today, everyone.
Great, yeah, so that's introductions. We're gonna just talk about each company here. So Alpha, we're a leader in the antenna wireless technology, and we've been around for a number of years. You know, Tim actually has a much more to say on this for me, so I'm just gonna pass it on to him.
Yeah, thank you everyone for joining us today. You know, Alpha Wireless, we've 15 plus years of experience in the 3.5 gigahertz band development. You know, since the inception of the company, we actually kind of cut our teeth on doing 2.5 and 3.5 gigahertz antenna designs. So when the inception of CBRS came around and the OnGo Alliance came to fruition, we were one of the very first OEMs to jump in from an antenna perspective to offer a unique set of solutions that will cover most any deployment type application. If not, we actually partner with different companies, and that's why we have Cameron with us today. You know, we actually work on different types of solutions and different approaches to help solve our clients' needs. We are a global company. We provide these type of solutions internationally, and it covers both LTE today and 5G tomorrow. So anything you possibly need, you know, these type of solutions, we have them in our stock.
Thanks, Tim. Yeah, so Alpha Wireless, we're the antenna manufacturers in this gang here, and then Cameron comes from Nextlink. He is I would say the operator, the wireless operator, but he's even more than that, and Nextlink. So can you just kind of explain, you know, what's Nextlink's about there?
Sure.
Cameron?
So Nextlink in general, we're focused on bringing rural broadband to every home that we possibly can through our footprint. We're currently in six states now, expanding into 7 states over the next 2 years pretty rapidly. We're under certainly a rapid growth curve. COVID obviously introduced the need for work from home, school from home, and we have been building network to keep up with that ever since. We're actually, since just in the last couple months, we've gone from 75,000 subscribers, almost at 78,000 now. And we're adding organically anywhere from 1,500 to 2,000 a month. So very, very rapid growth in the wireless space. We're seeing a lot of growth in our fiber to the home presence. We're doing a lot with centralized RAN. We're a big investor into CBRS. We're actually, I think, the 3rd largest license holder in the country with PALs, a little over 1,000 licenses, investing about $28 million into that spectrum. We certainly believe in it and what it's been doing. We hope to continue to build out our network across the footprint very rapidly to help get people connected.
Thanks, Cam. Just maybe a question for you is, what made you choose the CBRS spectrum? And any of the kind of qualities of it that really attractive to your guys' company?
Sure. You know, interference mitigation is certainly one. We operate a lot of 5 gigahertz equipment, proprietary 5 gigahertz equipment in a point-to-multipoint scenario. CBRS gave us some protections there with the way that spectrum had been structured. I was a longtime user of the old 365 gigahertz NN license rules, and as CBRS came to fruition and became OnGo, and how that came to be with the spectrum access system and kind of more fair use of that shared access spectrum across the country, made it advantageous for us to invest in, and obviously getting priority access licenses in there further cemented our need to have some protection to make sure our customer experience was positive.
Yeah, it seems that you know, the CBRS was almost the perfect catalyst to Nextlink to grow, because it gave them everything they needed, you know, in order to serve these networks, and having a standardized solution, which I think we'll be talking about here shortly. So as Nextlink, you know, you're growing, you're coming into those growing pains, and using traditional solutions from the WISP world wasn't really being feasible, like, from a reliability standpoint, even the cost of deployment. And I think that's where we came in at Alpha Wireless, is we wanted to help them bridge a gap and bring them a very innovative solution that helps them, you know, solve issues that we're seeing in wind loading, putting too many towers on the antenna, the time to deployment, which at the end of the day, when you are expanding as much as Nextlink, that's not always in-house time. So you want to make sure you're minimizing the amount of time at the tower, on the ground, doing as much, you know, pre-building as you can back in the warehouse, where it's a very controlled environment. And you know, the dollars per hour is much lower to kind of get everything set up. And in addition, you know, the end goal here is just to add more capacity. You know, it's not even just greenfield sites, it's existing sites, and upgrading them to kind of support new technology. So you know, we worked closely with Nextlink to kind of hone in on some solutions that work great for them. And in the CBRS space, that was definitely a very strong candidate. So Cameron, anything else you want to add to that before I kind of get into the strategy?
That was a pretty good summary, Justin, of kind of what we're up to. We had certainly had some challenges, not only from a deployment strategy perspective, but making sure that we're being very smart with our capital expense, and obviously having a positive impact on our operational expense. So all those factored into some of our decision making.
At the end of the day, it is a lot, you know, we're businesses, we're running on dollars, you know, that's what we're trying to maximize. But as an internet provider, we also want to give a very reliable level of service, because it's the quality of service which will keep the customer. So anyway, you know, we know why we want to do this. Now we're going to show how. So how we did this was we did, well, Nextlink did 2 deployments, 2 frequency spectrums that they standardize on. I'm not going to say I know all their plans, but this is the part I do know. So they took 3 65-degree sectors in the 3.5 gigahertz space, and they array them around the tower, equally spaced, 120-degree intervals, and that would be for the 3 gigahertz cell. And they populate those at different areas. Now, 3 gigahertz is great because it's you know, relatively good propagating frequency. Works great in non-line of sight, so you can get through trees to an extent. But you know, the end goal here was just to get that coverage within the first 4 miles. So this type of solution allows you to do that, get you know, the right signal strength you need to be get the right modulation. And it also minimizes having to put too many antennas on the tower, overloading it, you know, more radios and so forth. So that's the 3.5 gigahertz space. Now, when you go up to a 5 gigahertz, we have all that unlicensed spectrum. A lot of cases, you know, it's much more, you know, easier to kind of set it up, but you have to deal with the interference and so forth. But let's say you're lucky, you don't have to really worry about, you know, interference from a neighbor. The 5 gigahertz has that higher loss, higher free space path loss, as we say. So 3 sectors, it's going to be tough to do it. You know, you're going to have gaps in coverage. You really got to go up to your 6th sector, which we see in the middle here. Unfortunately, that's a hefty beast there. You know, putting 6 antennas on a tower can cost a lot of money, not just CapEx, but OpEx. So we came and we introduced a solution for them. It's a twin beam solution, which puts 2 of these 65-degree sectors. We packaged 2 of these into 1 radome. So if these are each 4 ports each, these sectors, this is an 8-port sector. 4 ports point left, 4 ports point right. And then when you get 3 of them around the tower, it acts like this. You get this level of coverage here, minimum gaps. And it works wonderfully, by the way. So this was a very great solution to you know, half the weight on the tower almost, reduce the operational expenses to install 5 gigahertz, and then it's also standardizing on what they're doing on 3 gigahertz. 3 antennas on the tower, that's pretty easy to set up. Now 5 gigahertz, it's line of sight. So that's, you know, choosing which one you're going to do. That's up to each environment. But at the end of the day, they're just trying to maximize spectral efficiency in each region and provide that highest capacity they can. So here just a little bit of notes on 3.5 gigahertz and the antenna we're providing. This is kind of the workhorse. Tim's seen this antenna every which way in that. So maybe Tim, do you want to kind of chat about this one and what makes this antenna work for CBRS?
Yeah, definitely. So what makes this really kind of our workhorse is this is like a really prime antenna to be able to support LTE type deployments. Like Justin mentioned, this concept of LTE in this band is a very optimal type of a solution because it allows you to get to the non-line of sight type of deployments. A lot of the operators like Nextlink, when they're deploying the 5 gigahertz or even the old 3.65, if you didn't have line of sight, you were having challenges with your bit rates and stuff. So with the introduction of LTE and here with OnGo and their new spectrum sharing approach, this particular solution allows different operators to use 4T4R. There are some that actually are using this in a split mode where they're using 2 radios of 2T2R with a frequency stacking on it. And then one of the things that we've also done as we've kind of evolved this platform, we've actually made this platform a little more efficient by adding in efficiencies in the actual antenna itself because it performs very well before, but now even with our latest version, our version 2 of this, the phase shifters and everything else we use in it are very high performance type of solutions. It's a tier 1 grade antenna, so anybody using this, even in the fixed wireless space, is going to be able to realize and enjoy the benefits of great front to back ratios, very linear gains throughout the spectrum band. You're going to have very good control of your RET, and we really control the side lobes too, because that's another big thing when you're talking about wireless networks. You're controlling your upper side lobes. We actually took it a step further in the designs and optimized those upper side lobes. So it's a really good performing antenna. And Cameron and his team has actually done a fair amount of testing with it and have verified, the performance aspects of this.
Great, thanks, Tim. Yeah, we'll kind of touch about what each aspects, how does that translate to network performance. Upper elevation side lobes, if we're not all familiar, it's these side lobes in the vertical pattern that are above the main beam. You want them to below 20 dB. Why that helps is when you're tilting the beam, it helps to reduce interference to the next cell, so you can pack your cells a little more closely together. Null fillings hasn't been talked about too much, but it provides signal below the main beam, good coverage right close to the tower within the first 500 feet or so. But yeah, we'll kind of talk about how this antenna helped in their deployments. So Cam, I don't know if you're very familiar with this specific one. It's one of hundreds, thousands. But what's the reasoning in going about doing these type of deployments, where you're placing the towers, and which frequencies you're going to be using?
Sure. So the placement always comes down to the planning and engineering. We have a really good planning and engineering department that selects, sites obviously based on households passed. It's going to be the biggest factor, but also where we have assets such as fiber backhaul and other transport mediums that make economical sense for us. Then as far as the spectrum use, we went through a pretty good spectrum process that allowed us to assign our channels early on before the priority access license launch. There were some channel swaps that came in place as part of that as well. But the biggest, most advantageous component to this is when we set up network neighborhoods effectively. Every one of these sites are operating on the same set of channels. So we're using reuse 1 across every one of the sites here you see in the screen, which allow us ultimate spectrum flexibility in the sense of how efficient we're being within the band. We're trying to make sure we're being good stewards of the band, not just gobbling up unnecessary channel assignments in areas that don't make sense. So we are taking the reuse 1 into account and accounting that into our projections when it comes to the capacity on a per site basis. With that, we do have the ability to leverage the PAL licenses that we do acquire, but we also have the ability to stack on GAA spectrum if we have a capacity need in that market. And to date, that's been a pretty good experience using the SaaS vendors. We're using the Google SaaS in this case on this particular example, but we do have relationships with others, and they all seem to work very well in their respective areas. But this has been a a good test case for us in the Bryan area here in Texas, and that has been a good coverage model for us.
Yeah, that's great. So, I mean, to get that frequency reuse one working properly with this density, I mean, these are about 5 miles apart. I think this is maybe 6 or 7. You have to have a pretty darn tootin' good antenna. So, even just on one tower, the front to back here needs to be good. Yeah, they're on separate channels, but being able to make sure you're not interfering with the adjacent cell in this tower next to it, where the A is pointing in this, pretty much the same direction. So, or opposite directions, I guess. But that's an important issue. The other is just the upper elevation side lobes. How much do we have to tilt down before we're not going to interfere with that cell? And if you have to go to extreme levels of tilt, you have an upper elevation side lobe that can be pointed at that next tower, increasing the center at the cell edge. Yeah, you'll still get your signal there, but you're just not at the modulation you need to get that data rate you want to deliver to the customer.
For sure. That's what we're focusing on a lot, is making sure our CINR is at a level that we can project to be very successful in a fixed wireless access application. Everything's about data and how fast we can get it there. So making sure we're controlling those levels to make sure modulations is where it needs to be is kind of the name of the game for us, even in a reuse one scenario, which we are in this area.
Yeah, so this is a map that was generated, and you can see this is very good levels of coverage here. A little dips here, but this is all terrain based, right? But this is a very strong signal, even at where they're intersecting two cells. So this is a very well thought out RF plan.
Thank you. I'll let our team know.
Yeah. So that's the 3 gigahertz side, and 3 gigahertz is great because it's planned spectrum. When now we're just going to briefly talk about 5 and 6 gigahertz, which is it has its own set of challenges and also its benefits. The channels are a little bit wider. We got more channel space available typically, as long as we're not interfering with someone else. And based off my experience, operators work together on this, right? If you're operating in a space with another guy, you try not to do that. What's your experience like, Cam, with being in this space right now?
Yeah, I mean, it doesn't do anybody good if you're not playing nice with the neighbors effectively, because the only person that ends up suffering is the customer. So we do have some good level of communication with those folks, and we're certainly open to obviously receiving communication as well. This particular antenna setup that you have here, we use the 3.8 AW3802 in our deployment, and one of the things we got more efficient based on our previous configuration is we actually got more spectrally efficient because we're using less overall channels on a per site basis. So we were previously using 4 different channels of bandwidth on a particular site, and we've reduced that to 3. So that alone has been pretty valuable where it comes to co-location on either a site with a competitor or just a neighboring site that may be near close. But it's worked out pretty well in that regard, be able to save that channel space for other use.
Yeah, that's great. So it's the same frequency. Well, no, it's the frequency reuse 3, I guess, because you're using 3 channels. But it is similar to 3.5. You're still only putting up 3 sectors. You just have to use an extra couple channels to kind of achieve it, because on the interior it is 6 sectors in total. So going down to the 6 to 3 allowed you to just not even just get that spectral efficiency savings, but also the OpEx savings, because now you have just one mounting point for the sector, so less tower rental if you're renting that tower, and then being able to get both of the radios on the back of here with the GPS unit on top. This is something you're assembling in the warehouse with a team of guys who are kind of getting efficient at it, really good, and can really just start popping it out. As opposed to in the field where it's a new morning and 8 o'clock in the morning you're trying to assemble an antenna in dawn. So yeah, I'm glad this solution is working.
There are a lot of operational efficiencies that come when we can build things in a controlled environment. We can QA them a lot better to make sure everything is wrapped up the way it needs to be. Everybody's following our standard operating procedures. For me, our tower crews are best spent vertical. I'd rather them not sitting on the ground, putting connectors together and things like that if they don't have to be. So anything that we can alleviate them to make them more efficient with their time at a tower, get them there, get them out, is super valuable to me. The tower teams have also provided great feedback to us in our early design phases of this antenna. And one of my favorite reasons for partnering with Alpha has been that they were very quick to be receptive to those and make changes based on the mechanical feedback from our tower crews, and that goes a long way. We can engineer stuff as best as we think is possible from the ground, but even as a former guy that's been on a tower myself, I can appreciate what it means when we make adjustments so these guys can get stuff done quicker.
Oh, that's great. No, glad to hear this is working.
Yeah, you bring up a good point there, Cam. On the approach that, from Alpha Wireless, we like to try to take on the operator's mindset. I myself came out in operator's space for 16 and a half years. So when we partner with companies like yourself, we try to put that thinking cap on and say, how can we do things to help you guys resolve your issues in deployments, and build business cases to show you how fast things can go, how much money you can save. Like the case in point with putting these together in a warehouse, you can save as much as 50% or more in some of your site deployment costs, because you're not having a 6-man crew or a 5-man crew standing around waiting for radios to upgrade, or someone to find the right washer because they dropped a washer from the tower top, and those type of things. So a lot of little things like that make the deployments go really well. And from an OnGo perspective too, we take that same type of approach, like not only we do with their 5 gigahertz stuff, but we're doing the same thing in the 3.5 gigahertz with some of those, which we'll talk about here in a little bit. Justin will highlight one of the things that we've done there too. So
yeah, I think we can move on here. We do have some more to share. So this is just a little bit more details on the 5 gigahertz. Really, we kind of ran over this and some of the network performance. I don't want to belabor it too much. So let's get to the kind of interesting thing we were just chatting about here, Tim. So very similar solution to kind of what we talked about, taking 2 sectors and put it into one. But instead of doing a 65-degree sector, this is a 33-degree sector, and this is designed for 3.5 gigahertz. So you put 2 of them in there. They're angled at 60-degree spacing and 33-degree beam widths. So you get nice coverage with just one sector. It kind of acts like a 65-degree sector in a sense by itself, except you get 2 ports going left, 2 ports going right. So great for 2T2R. And then you put 3 of those on the tower, and now you got your complete 360-degree coverage, where you got just sharing 2 channels. Because of these side lobes on this antenna, we spent a long time optimizing these side lobes to be below 25 dB across this entire band. So, that's how we are able to achieve this level of spectral efficiency. And in addition to that, this has the same benefits as our 65-degree sector, and that the upper elevation side lobes are very suppressed, and the front to back is excellent. So this is gonna be a great tool in the tool belt for these high capacity sites where you just need to get as much throughput and capacity for a very dense network, let's say, or for very demanding customers who need that level of throughput. So this is just another solution which helps reduce the tower count or antenna count on the tower and all the benefits that come along with it. Yeah, so I think Cameron, do you have anything to say? I know that these aren't the only antennas you're looking at and using. You deploy a lot of different solutions, but it's not about just getting the standard antenna. It's about finding an innovative solution for that application.
This particular conversation is bounced back and forth with Tim and I and you for a long while. And one of the reasons, particularly in a fixed wireless application, is we don't get necessarily the benefits in the rural areas where we are trying to get as much capacity out of a cell site as possible. In the urban areas and the suburban areas, it's very easy to achieve, or not necessarily easy, but easier to achieve 4-layer MIMO. But in the rural America that we're deploying in, 2-layer MIMO is the reality. So in order for us to increase site capacity without layering on things like multi-user MIMO feature set, we are doing split radio, 4-port radios, and we're going to dual 2x2. So we're able to get that aggregate capacity increase and utilize all 4 ports of the radio more effectively without a significant increase in our capital expense. We're using the same exact radio hardware, just a configuration change from a software perspective, without dramatically increasing any footprint in the actual antenna design. But as a benefit, by switching into the 60-degree twin beam antennas, we're also getting increased gain by having the narrow beam width of 33 degrees. And the biggest challenge of most fixed wireless LTE networks is going to be in the uplink saturation. So we spend a lot of time and care to make sure that we have good uplink capacities across the cell site to maximize our downlink capabilities. So with that, additional gain helps a lot in our uplink side as well. So we do take some time and patience to make sure that we're delivering in those areas as well.
Yeah, Cameron, you touched on a very good point there that you know, maybe new LTE engineers haven't really grasped yet, is that imbalance between forward link and reverse link. And like you say, from this particular solution, we know that within the OnGo in the CBRS Alliance, you know, it's defined on what the max EIRP outputs are. But you know, even using a 20 dB gain antenna, it does help you overcome some of your reverse link challenges. So even though you may have to pull the output power of the radio back a little bit to adhere to those EIRP limits, you're actually gaining reverse link coverage, which is very paramount for your actual cell coverage, your performance of the network itself. And you know, those type of things were really, you know, thoughts of minds for people to think about as they're doing their designs in the networks.
For sure, and that's just in the LTE part of the conversation. I mean, most LTE radios support 64 QAM on the uplink. I mean, we're definitely looking towards the future of 5G with our CBRS deployments and leveraging 256 QAM on the uplink to really increase those capacities to the user. You know, we're mostly excited about that. We're certainly excited about the latency improvements that 5G offers. So we're really anxious to get that going in CBRS, and we are in the midst of conducting testing on that actually right now. So we're pretty excited to where it's going to go. We're excited that we have this spectrum to do it in, and all the partners that have been coming through. And partners has been an overused term in the last 4 or 5 years. So I don't take that lightly on who we're working with to get this stuff accomplished.
Yeah, you're right on the partnership side. You know, to make this system work, you know, end to end, there's a lot of partnerships that happened. You know, a lot of learning curves that go on, that's gone on since the inception of it. One of the, you know, just a key thing that we've learned, you know, you touched on it earlier about the SaaS vendors. You know, that the host of SaaS vendors. So we've had to really kind of pivot on how do we do our pattern files, you know, to support not you as a customer and your tools, but we also have to support, you know, the different pattern files for Google and Federated and some of these other guys to be able to import our pattern files into their SaaS servers. So when you go in and do their link budgets, it knows how to do that power estimation, your interference estimations, and that type of thing. So, you know, it's been a very good learning curve, and you know, we're excited to see where this really takes off and goes to.
Well, so far so good for us. We've been pretty excited about it. We're deploying about 25 sites a month right now at a macro level, and we anticipate that to increase pretty rapidly to 50. And not to mention even just the small cell component that's starting to leverage in, and I'm sure additional antenna products from Alpha will help us get there.
Yep, absolutely.
Well, thanks, Cameron. Thanks, Tim. I think we discussed this greatly. So I just want to thank the OnGo Alliance.
Thanks, everyone. I really appreciate it. OnGo Alliance has been helpful. Been working with you guys for years. It's a lot of work to herd all the cats, and we're definitely excited to be deploying in this spectrum and continue to see where it's going to develop into.
Yep. Thank you, everybody.
All right. Thank you very much, and signing off. Bye-bye.